Welcome back to my channel, SF with AK. This is Aman Kumar and I am a 22 times certified Salesforce developer. If you write Apex for a living or even just for fun, you've probably heard the phrase design patterns. Maybe in a code review, maybe in a job interview, or maybe you have seen it somewhere in Salesforce architect documentation and quietly skimmed past it. Today we fix that. In this video, part 1 of a 3-part series, I'm going to walk you through exactly what design patterns are, why they matter for your Salesforce development career, and then we're going to break down 3 of the most important ones: Singleton, Factory, and Builder patterns today. By end of this video, you will have real working Apex code which you can take into your org today. Let's get on to it. Okay, this is the roadmap for today. 6 sections, nice and clean. We'll start with mental model. What is a design pattern and why should you care about this, or why should you learn it? Then we'll look at the 3 categories that all the design patterns fall into, and then we'll start by creational pattern. 3 types of creational pattern: Singleton, Factory, and Builder. Each pattern will solve a different problem. Each one will make you code cleaner. So let's start. What is a design pattern? So a design pattern is a reusable, proven solution to commonly occurring problem in a software design. So design patterns are not invented by one person. They emerged over decades as developers across the world kept solving problems and noticed that certain approaches work consistently better than others. 2 things I want to say. First, it's not a copy-paste code. It's a design pattern, is not a snippet you can go off as Stack Overflow, and it's template for thinking. It's a way of structure and organizing your code so that it behaves predictably and holds up over time. So when a structural engineer designs a bridge, they do not start from zero. They have established structural principle, load distributions, tension, compression, and all those that have been tested over hundreds of years. A design pattern is the software equivalent of that engineering knowledge. Developers before us ran into the same problems you are running into right now, figuring out the best solutions and give those solutions names so we can talk about them and reuse them. That is all about design patterns. So now the question, why should you learn about design patterns? You might be thinking, this sounds great in theory, but will it actually change anything how I code day to day? So let me just tell you. Here's an honest answer. You can build Salesforce applications without knowing design patterns, but at some point you will notice a problem. Your trigger handlers are very long, 500,000 lines long. Your service class has a dozen of if-else blocks. Adding one new feature means changing the whole code in 5 different places. A new teammate joins and cannot understand the code you have written, and you need to sit with them and explain the code for hour-long sessions. Design patterns solve all these problems. They give you a vocabulary and a toolkit for writing code that is readable. Another developer or future you can pick up your code and understanding what is happening without needing long overview walkthrough. That is priceless on a team level. Number 2, maintainable. You can add a new feature without breaking existing logic. Months after you wrote it, structure still holds. That is the goal. It should not break even in future. Number 3, testable. Each piece is isolated. You can unit test it independently without having to fight through all of dependencies. Your test coverage goes up, your bugs go down. Then comes the 4, scalable. Whether your team is 1 developer or 100, the architecture holds up. You are not accumulating architectural debt or technical debt that will bite you later. That is how the design pattern helps you. So these 4 qualities, readable, maintainable, testable, scalable, are what separates good Apex from great Apex. Design patterns are the most structured path to all 4. Before we jump into the code, let's orient ourselves with the big picture. Every design pattern in existence fall into 3 categories. Creational patterns answer the question, how the objects are created. Think it of like a barista. You woke up, you place the order, and the barista handles all the details of making it. You don't know how the espresso is pulled, you just get your coffee. Creational patterns are about controlling that creation process. Today's video, it covers the creational pattern, Singleton, Factory, and Builder. Second one is behavioral pattern. That answers how do the objects communicate with each other. The analogy here is orchestra. Every musician knows their specific role. The violinists don't try to play the drums. They are coordinated but decoupled. Part 2 of the series will cover behavioral patterns. Then there's structural patterns. This answers how the objects are organized, like Lego blocks. smart composable pieces that fit together cleanly. Part 3 will cover the structural patterns. For every pattern, we'll follow the same structure, the problem it solves, a real-world analogy, an Apex code example, and the key takeaway. Now let's start with the creational pattern. So the creational pattern are 3 types of patterns. First, Singleton pattern. 2, factory pattern. 3rd, filter pattern. So in Apex, this matters more than you might think, because in Salesforce transactions, how and when you instantiate objects affects memory, governance, consistency, and testability. Let's start with the singleton pattern. Core idea behind the singleton pattern is it only has one instance of a class in each transaction. Here's the problem that it solves. Imagine you have got configuration class, something that holds org setting, custom metadata, custom settings, values that are org-wide same. If that class get instantiated multiple times across your transaction, you are wasting memory and risking inconsistency. 2 different parts of your code might be reading from the 2 different instances. And if one of them gets out of sync, you've got a bug that's really hard to track down. The analogy. This is Salesforce specific, and I love thinking about org-wide defaults in your Salesforce org. There's one set of OWD settings, not a different OWD per user, not a different per profile, one central configuration. That is a singleton thinking applied to the platform itself. When you should use this, when you are working with configuration and setting classes, logger and audit reliability classes, cache management, or any class where having 2 separate instances of a single class can cause a problem. And here's the key takeaway. I want you to remember 3 things that make a singleton pattern: private constructor, private static variable, and a public static get instance method. That's all about singleton. Now let's see how this is in the real code. We discussed the 3 takeaways. Private static variable. This is the private static variable that I was talking about. The singleton class variable or instance which will be used and written. Then the private constructor. The constructor is private because we don't want people or other classes to call it from outside. We want it to call this public method. We have a public static method which will use from any other class. We'll call the get instance method, and that will check if the instance is there or not. If instance is also already there, we will just return that instance. Otherwise, we will start the class or instantiate it and then return that new instance. That is how you write a singleton class. Let me take you to the Apex and show you how it actually works. Okay, so this is a singleton class that I wrote. It's a very basic class. I have my private constructor, private static variable, then a public variable to hold the setup metadata, then a private constructor that will just query this metadata, and then a public static method to get the instance. Now let me show you the difference. So these are 2 instances of the same transaction. Let me call this and let's see what happens. So we just started the instance here at line number 7. So this is the instance number that was allocated to that instance of that class. After that, we queried and stored that in the variable and then returned it. Now, again, we called the same class again. This time, we just returned that same instance along with the same metadata. We did not start a new instance. If you see, throughout the same transaction, this instance is the same. It has been used multiple times. That is the power of singleton class. Now, let me show you the difference if you don't use it and directly call the constructor. Make it public so that I can call it directly. And let's just call the constructor, nothing else. So now this time we just called the constructor directly without using the static method. Now this was assigned to the constructor variable, so this is E9E, and again when we call this again, you can see there is a different instance of that same class, that is 53E. So now we have 2 instances of the same class. We made this query inside the first constructor, and we'll have to make the query again when we call the constructor again. So that is how you save the memory or make the process faster with a singleton class. So in this one, it did not query the second time. It just returned that. So we started the instance, found the instance, it returned it, and we have the metadata. There's nothing that we need to do separately for the other instance. Let's move on to the next. Okay. The next pattern is factory pattern. Okay. The core idea behind a factory pattern is delegate the decision of which object to create to a central place. Here's the problem it solves. You need to create different types of objects based on some condition, like send an email or SMS or Slack notification. So the one approach can be scatter if-else block everywhere in every class that we want to use, where we will be sending the notification. If this type is email, then do this. If this is SMS, then do this. And we'll write this if-else logic in each class. The problem, that logic is now duplicated across your code base. So the same if-else blocks are multiple, on multiple classes. Every time you add a new channel, you will need to update each class at multiple places. It's fragile, error prone, and it will be, a nightmare to maintain. The analogy that I can think of, same coffee shop, you go into a barista or any coffee shop and just say, I want an espresso. The barista decides which machine to use. There can be multiple machines, but they decide which one to use, which beans to use, which process to use. You don't know or how it's made on the back end, and you don't even need to know about that. You just get your coffee. Similar way, the factory pattern works the same. The caller asks you something, the factory handles the decision about how to produce it, and we're good. When should we use it? So integration adapters, connecting to different external systems, notification senders, multiple types of notification that we need to send, we can use there. Report generators, any scenario where the type of object needed is determined at runtime. We need to determine at the runtime which type of object we need to create. Then we should go with the factory method. So your business logic should depend only on the interface, never on the concrete class. Adding a new type means adding one new class and one line in the factory, and you should be good. That is the power of factory class. Let me take you the class. Okay, this is something how it will look. So we have an interface, we'll have different classes, we'll have a factory method where we'll decide or write the business logic on which type of email or what we need to return. Let me show it to you on the Apex side. So this is my factory interface with just one method, send notification. Now I have multiple classes. For email, I have one. SMS, I have one. Slack, I have one. I'm using the same interface, factory interface. I'm using the same method to pass the data. Now inside the method, I can do anything. The logic can be different for email. It can be different for SMS and for Slack. In the notification factory, I will just use the type and return that class. So if this type is email, I will just return the email processor. Once the class is there, I will be able to use the method, send notification, and pass the data. And it will run the same logic. If it's SMS, it will return the SMS processor, and I will be able to use the same method. So let me show you how we can use this. Okay. So this is the factory interface that should be written that will give me the instance of the interface. Now I'm using the notification factory class where I have the logic of which type of email or notification that I want to send. Let's say I want to send an email. I just started the class or created an instance of the same class. Now I have this send notification method, and let's see what it does. So this is an email notification. So it ran the email processor class and it printed this system debug. Now let's see if I want to change it to SMS. I just need to change the type that I want to send. Rest of the code will still be same. So let's see what happens. This is an SMS notification. So the logic in the SMS processor class that is done now. So similar way, you can just change the type that you want to send and it will change the whole logic. You can have everything written in one class. And if you want to add more types of notification or maybe something else that you are doing, you can just change the logic inside the notification factory class, and you just need to create one class for that. You can write the same logic or different logic in that specific class, so that in future as well, If you need to change something in one class, other class are not affected. That is how the factory pattern works. Go back to PPT. Now the third pattern, the builder pattern. So we construct complex things when we pass 8, 10 variables or 10 input parameters. We might, miss the order. If we are passing 10 things in a particular order, we need to have the same order at multiple places, and that might, ruin our logic. What we need to do with the builder pattern, we just need to define the class, and it will have its own methods. We'll just call those methods, and we'll have a builder class. You will better understand when we see the code analogy here. So when we order laptop online, you choose the processor, you choose the RAM, storage, color, and all these are independent selection that we do. Or the order does not matter. In whichever order you want, you can choose these. If something is required, when you click on hit build or buy, it will give you an error that you missed this particular part. That is the builder. So the system takes your configuration, validates it, assembles everything, and then gives you an output or a validation. When do you use it, or when should you use the builder pattern? Salesforce record with multiple optional fields. It can be custom object or case object or any other object that you have, but with multiple fields that you need to pass from one class to another class. Complex HTTP request. So if the HTTP request has multiple parameters that we need to pass, then we should be using the builder pattern. And any object where the construction process needs step by step. Let's see it in Excel and how the code looks like. Okay. This is how the code will look. We have a case builder class where we have different methods. We have a case record variable, and we have different methods like set subject, set priority, and we just have one method where we build the case. Let's see it in Excel. Okay. The last class that I have is case builder. In this, I have three methods: set subject, set priority, and set description. And the fourth one is to build it out. Now I have a validation. If subject or priority is blank, it should throw an error, and it should not allow me to, return the case. I have the subject and I have priority. It will return the case report. Let's see how I call it from other classes. So let's say this is my case variable, C, and I'm just using the case builder. Now I can just directly, if I'm using the old method or the normal methods, I will just pass like here. I'll pass subject, I'll pass description, and it needs to be in a particular order. If I miss the order, it will break. So that is when, the builder pattern comes in. Now I can set the subject before the priority or, change the order. So let me just run it. And we have a case variable. Now, even if I change the order, let's say I want to set the priority first and then the subject, it will not matter. So we have the same case variable. That is the, beautiful thing about builder pattern. It does not matter which order do you choose. As long as you have the required fields, it will work. Now let me show you how it will throw the error or the validation will run. So let's say I will pass the subject as blank and then try to build it. So it will throw the error. Required fields is missing. Now I can check for each field separately and throw the error as well. So let's see. Cut it from here and I'll just copy paste this. So I can just say subject is missing. I can just say priority is missing. I can save it. Now that will give you, more readable exception. Subject will be missing. That is how you use the builder pattern. Let's go back to the PPT. Okay. Well, that is everything today that we had to discuss about the patterns. Now, we covered 3 creational patterns today. Each one solves a distinct real-world problem. Singleton, one instance controlled creation, no duplicates, shared memory, use it, shared resources. Then the factory, centralized objectives behind an interface, the caller never knows and never needs to know. Then the builder code, builder pattern, construct complex objects setup by setup, the fluent validated change, eliminates the error-prone, unreadable, multi-argument constructors that we use. Together, these patterns are foundation of clean, scalable Salesforce architecture. If you apply, any of these in your next project, your code, it will be better. Well, if you got value from this video, hit the like button. It helps the channel more than you can think. And also, if you are not subscribed yet, now it's a great time because part 2 will be coming soon. It will cover the behavioral patterns, that is strategy, observe, and command. And if you like the video and learn something, do let me know. And if you have used these patterns before, please post me comments. I will love to know. Thank you.